Okay, sorry about that. So let me share my screen again. So the course goes with Palo Alto ASA FTD, Big IP F5 LTM, Checkpoint, and FortiGate. So this demo is specifically for Palo Alto, and the course will be a weekend batch, and we'll be starting with Palo Alto from today. Um, so with this course, what basically you would get? So you would be uh, taking up this course as a weekend course, and it will be a 5 firewall module all in one bundle. And you'll be given with 5 months of lab rack server access from our side. You don't have to worry about your local machine, how much RAM it's going to handle, whether it'll be sufficient for you to um, run all the devices to practice the labs with the topology that we are providing. So that has been taken care from our side. And you also will be able to retake the batch if required, if you would like to have more insights on classes that you have missed or something like that. So you will be having an option to retake uh, the complete course if required from your side. And with regards to lab and any backend support, you will be having 24/7 support from our side. Okay, so what about the recordings? So you will be provided with the recordings and the study materials. Most probably, the with respect to Palo Alto and FortiGate, we will be covering up the uh, complete syllabus of that specific certification. So with respect to recordings, you'll be provided with recordings, and you will have lifetime record access to the recordings that you will be provided with. Okay, so what the lab topology would look like. So if you take Palo Alto for an example, so this is how your lab topology would look like. So it's going to be one single lab that you will be working with. One second. So it's going to be one single lab that you will be working with, and you will have to, you'll be provided with this specific lab. Let me try to maximize this. I'm not able to open up the lab for some reason. So this is how the lab for Palo Alto. So this is how the lab would look like for Cisco FTD and ASA. So this one will have FMC, FTD, ASA clubbed together, since it's all belonging to Cisco platform, and this will be for Palo Alto. So this will be the lab that you would probably be provided with, maybe with a few modifications, just in case if I had to add or modify something to it, I will do and then provide you the final lab in the next upcoming sessions. So similarly, you have a separate lab created for you guys for all the modules that you will be enrolled with. And the syllabus curriculum, you could go ahead and review all of them by yourself after the session whenever you get time, so that you know what exactly is within the section or within each module that you will be learning. All right. Okay, so if you have not yet enrolled, you have an option to enroll at last for your classes, and you will be also having a multi-vendor lab at last, which has ASA and Palo Alto clubbed together. So maybe we will be having a session on building a VPN tunnel between ASA and Palo Alto, and if we had to consider having 2 firewalls in an environment, in a corporate environment, and you will have to probably play with 2 firewalls together. So for any questions with regards to, and of course you'll be provided with the certification at last once upon successful completion of the course. All right. So for contacts, you can just take a screenshot of this page to contact the contact our team in case of enrollment or any queries in future after enrolling. All right. Okay. So I will keep the forum open for you guys to get yourself introduced. I know I have about 100 people in here, close to 100. So I will not be um, it's not ideal to have everyone introduce themselves in this forum, but probably to know the essence of how what sort of audiences that are in this forum, we shall probably give it 5 minutes with probably 30 seconds for each of us to get introduced, and we shall get started with the actual session. So exactly 5 minutes from now. So anyone would like to take a call?
Hello.
Yes.
Good evening, sir. My name is Rahul Singh Patel.
Hi,
Basically,
Rahul.
so firstly, I was working with network team, and there I was working just on LAN. And recently, I was working with some project that was related to also some LAN and desktop. So I was came to know about this class and this session
Okay.
with one of my friend, that is Nipun. So I really thanks to Nipun for sharing this, and I think this will be helpful for me because I have little bit knowledge about security, but I have never worked on that. Like some ideas, IPs, like firewalls get blocks the IPs that are some malicious IPs, so like something like that. So it's
Okay.
totally about security. That's from my side. Thank you for this class.
Yeah. Thank you. Thanks a lot. Thanks for the introduction. So anyone else?
Yeah, this is Vimal here. I'm a network engineer. Looking
Mhm.
forward to looking forward to enroll myself in the security career. As of now, we are handling only the switching and routing, and but it is essential for a network engineer to get mastered in the security side also. That's why I have enrolled here. This also referred by my friend. And thanks.
Yeah. Thank you. Obviously, it is absolutely necessary for you to get into network security if you are a network engineer already. Uh, that's something we'll be talking about after the introduction as well, why network security is important in the market. All right. Anyone else? I'll be having it open for 3 more people to introduce you guys, and we shall get started.
Hi, Navin. Am I audible?
Yes, you are. Yes.
My name is Ruben George. I am working for a system integrated company, working as a senior technical consultant, taking care of network security and collaboration as well. I'm in the network security. I'm handling all the products for the projects and on service based for our clients in UAE. In terms of firewall, I'm handling the Cisco firewalls and the Palo Alto Checkpoint Fortinet and Sonic Wall as well. I'm holding a CCIE in security as well. Currently, I'm planning to do the F5 load balancer, LTM and GTM as well in future.
Okay.
Yeah.
Great. Thank you. Okay. Anyone else who would like to volunteer?
Yeah, hi, this is Narayan.
Hello.
Thanks for conducting this session. So I would like to ask, are you going to cover the automation part also in this session, or?
In this session, not, but the course will have a little bit of automation, how you will be able to automate your firewall activities through API calls.
Yes.
So we will be covering that a little bit. Yes, it will be covered with respect to Palo Alto, but not in this demo session, but definitely at the end of the Palo Alto course if you get to join us.
Yeah, thank you.
Thanks.
Hello.
Hi.
Hi, my name is Odunla. I'm from Nigeria. I'm currently an IT support engineer. I have a little understanding of like layer 1 and layer 2 networking. I'm currently working towards getting my CCNA, but my final destination is actually network security. I got to know about this training through a friend on LinkedIn who sent me the registration link. And to be honest, I am so happy to be here and I'm looking forward to learning a lot about network security.
Great. Thanks a lot.
Morning.
Hey, good morning.
I'm James from the US, based in Minnesota. I did a couple of training with network joining. I did my CCMP with network joining. I recently worked with a company called Symbolic. I was a network installation engineer. But I've been trying to get through the track, but there was kind of conflict. And I'm happy to be here. Most of the job I've been applying for, they've been requesting security, Palo Alto, and FortiGate. So I'm happy to be here. Thank you.
Yeah, thank you. Thanks a lot. I hope we shall get started with this. We had about 6 to 7 people, and you see, we are all from different geographical locations, and it's happy to see so many people joining in for the demo session, and I'm hoping to see each one of you there in the main batch as well. Okay, so I have showed you the actual topology where we'll be playing with when we get started with Palo Alto or any firewall for that matter, anything in the bundle that you may take. So for the demo session, to make it simple, I will be covering a certain topics which I'll be putting up here in the notepad so that you know what we are going to do for these 2 days. So this is the agenda that I have planned to cover. So we will probably be looking at 3 to 4 topics of these 10 for today, and then we'll have the rest left for tomorrow. All right. Okay. Just give me one quick moment to open up my lab and to know if everything is fine. Okay, can you all see my screen clear? I have opened up my agenda in the screen and the notepad, if you could see that.
Yeah.
Yes, sir.
Yeah.
We can.
Okay. And my voice is also clear, right? Do you
Yes,
have
yes.
any? Okay,
Yes.
great. Okay. Okay. Once again, thanks for joining. Let's get started with the first agenda on. So since I said many of you are CCIEs here, and many of you are already into networking, working on routing switching, and you might already know what a firewall is. But since it's for each and every one of you who has joined here, who are also a part of some other domain, who wanted to get into networking or network security, it's for them to know what a firewall is and how does that function. So basically, it's for them to know how a network firewall would function and what it is exactly. So let's get things going with that first. All right. So when we consider, since people are already aware of routers, for example. So when you consider a router placed in a network, you probably have an ingress and an egress interface for any specific traffic flow you may consider. So let's say there is a switch and a PC connected behind it. All right. So you have internet going out from the router. So in this scenario where what security feature a router would do? So in your guess, if you would think of the router is a layer 4, layer 3 device. So it obviously will have an IP, and when the traffic reaches the router and when it has to get out. So this would be its ingress interface and this would be its egress interface, isn't it? So when it's going to be considered to act as a security device, so maybe you could do a zone-based firewall on a router. So considering it's not acting as a firewall, it's just a router by itself. It does routing and it does some sort of security feature, which in today's world, in modern world, we can't even say it's a security feature, but then some sort of security that it can claim to have is that it probably can do a IP filtering, isn't it? And probably can filter traffic based on port numbers. So this is done through access list. So when this when you consider router, it's not going to inspect anything where it does a flow inspection of inward and outward flow of a specific traffic. It's not going to do that. Rather, it's just going to check if the flow is towards the client to server from inside to internet. It's going to check the access list if in case it is applied to the interface, inbound or outbound on either of these two interfaces. It's going to check if the IP filtering or the access list is going to be an allow or a deny for the specific traffic, and it's going to take action upon it. Apart from that, you can't think of anything that a router might do in terms of security. All right. So then comes a firewall venture. So in this case, we're going to consider an ASA firewall. So what an ASA firewall does, so I'm not going to consider the part behind the firewall and after the firewall, but then just focus on the ingress and egress interfaces here. So when you consider an ASA firewall, it's going to do something called stateful inspection, which a router is not designed to do, or it's just not capable of doing so. So what a stateful inspection is? So when let's say a user is trying to reach somewhere in the internet, so he's going to come from a specific IP, let's say X, and going to reach a specific IP, let's say Y, for example. So in this scenario, let's say it's a TCP traffic. Let's say the total flow is going to be from client to server and the response back from server to client. So that's considered as one specific successful flow, isn't it? So when a client is trying to access anything in the internet, access any server in the internet, the return traffic or the response for that specific connection. So let's say the connection, for instance, for our understanding, let's say it's 1. It's the first connection sent from client to server. So the response for that connection will be coming from the server towards the client, or maybe if a data transfer happens after the TCP negotiation, the data will be traveling back and forth on the same connection. So what the stateful inspection does is that it's going to check the flow of the traffic, and it's going to keep track of the flow of the traffic. Let's say this is the session initiated by the client to server and the session number is 4152. So this session ID will be maintained on the firewall, or you can say it is a session ID or a connection ID in ASA terms. So this connection ID is going to be maintained in the Palo Alto ASA firewall, and it will be looked up when the return traffic comes to the firewall to get into the network. It checks if the forward flow for that connection is already there, and the reverse flow will be automatically allowed. So it statefully inspects the flow of the traffic. So if the connection is already available for the specific flow, the reverse flow that's been sent as a response from the servers to the client will automatically be allowed by the firewall. So that's one feature that you might considerably see in terms of a firewall to that of a router. So what else a firewall could, an ASA firewall could do? So it's basically going to be, we're going to call that as layer 4 firewall. Why? Because when you consider router, it's going to inspect only up to layer 3. When you consider ASA firewall here, it's going to inspect layer 3 and layer 4. So which means it's going to inspect traffic based on IP addresses and protocol or port number. So let's say FTP. So you got to inspect, if you say you got to inspect FTP, it's going to inspect FTP inward and outward. If you say inspect ICMP, it's going to inspect ICMP inward and outward. So likewise, it inspects the traffic on layer 3 and layer 4 as well. So that's why you call the ASA firewall as a layer 4 firewall. As usual, since router can only do some sort of IP filtering, ASA can only do something, some security features up to this one. So inspecting layer 4. So this also is getting deprecated slowly. And we are getting into an era where we are using next generation firewalls nowadays. And there are few leaders in the market for which produce or which has a next generation firewall leading their name in the market. So who are Palo Alto? You have FortiGate. There is a reason why I write Palo Alto on top. It is the leader in the markets, and FortiGate is catching up. So you have FTD from Cisco, and you have Checkpoint, and you have Juniper, Sonic Wall, and so on. So you can name a few as well, but considering the amount of customers or the amount of users who are using a particular next generation firewall, it's enough for you to know either of these 4 firewalls, and you can catch up learning other firewalls very quickly or very easily. Of course, you need to know the nooks and corners of how you configure them, but the leaders in the market are going to be these 4, and slowly FortiGate is catching up with Palo Alto, and who knows, they might 50 might come up with something new, and it might lead the market in future as well. So what new next generation firewall is going to do for us? So I'm going to consider any next generation firewall for that matter. In our case, Palo Alto. Okay, I have a similar scenario where a user connected to a layer 2 or layer 3 switch to the firewall and out to ISP router. Okay, so in this case, so the firewall, next generation firewall here, considerably a Palo Alto firewall, is going to do everything that a router or a layer 4 firewall ASA was doing earlier. So which is routing, and it's going to inspect layer 3, layer 4, obviously. On top of that, what else it can do? So it can do application identification. So what does this mean? So when you consider layer 4 ASA firewall, so it's going to inspect the traffic based on protocols and port numbers, isn't it? So that's what we said or we discussed earlier. So what's new with this firewall? So it's also going to do a service port based inspection or a protocol based inspection. On top of that, it's going to say, I'm going to identify which exact application that a user is probably going to use. Whereas, let's say a user is getting to Facebook, or he's going to Alibaba website, e-commerce website. So he's probably getting to Amazon. So it's probably going to identify which exact application the user is probably going to use. And if an application were to change in future, let's say he's accessing Facebook through SSL, which is HTTPS protocol through a URL, through a web browser. So the initial application for him or for the firewall would identify is SSL. On top of that, after getting to a login page of Facebook, after he logs in or before he authenticates, the firewall will identify that through some sort of methodology, it identifies the application as Facebook. Does it stop there? No, it also does something else. When he logs in and when he gets to chat with someone, it identifies that he is accessing Facebook chat, or maybe video, or maybe playing games, or he may be on an audio call. So it can identify the sub application within the main application on what exactly the user is probably going to do. So this applies if that specific application allows the decryption to happen, to know what exactly we are getting to see inside his main application. So if it's allowed for the Palo Alto to diagnose, it's going to do a diagnosis and then identify the sub applications that he will be a part of. Okay, so it's going to go this much deep to identify what exactly user is accessing. So it's very important in a corporate environment to know what a user is basically going through when he's browsing something, isn't it? So that's about identifying the application. So when on top of that, what else the firewall is capable of doing is that it also identifies the traffic based on the user's AD information. So user ID information. So that's that feature is called user ID. So what happens here? So when you check your logs, maybe again taking ASA as an example, when you check your logs, you will be probably seeing source IP, destination IP, source port, destination port, and protocol maybe, and allow or deny. So that's all you will see. So when you probably you're probably seeing something happening on your network, let's say ISP bandwidth is getting utilized more, and you wanted to figure out who is utilizing more, or if someone is downloading something, you have a dedicated GUI monitoring dashboard in your Palo Alto firewall to basically diagnose which source IP is basically accessing what, how many bytes of data he is accessing, and all those information, all the specifics can be viewed on your Palo Alto dashboard itself. But if you're going to view them as a part of an IP address of the user, you got to trace back the IP and check which switch it belongs to, where he's connected to, and from there which switch port the MAC address of that user is, the ARP IP is being learned, and the MAC address has to be traced, and you have to figure out the switch port of the user, and then get to the patch panel, and then finally figure out who the user is. And then it's something that it's a traditional way of identifying who is accessing what. Whereas when you consider utilizing a feature called user ID, you will be able to integrate your Active Directory. Maybe you're using a Windows AD, the database of the users to that of the IP will be pulled from the Active Directory. There is a specific configuration that you will have to undergo. So once that's done, your Palo Alto will be logging into the AD, and it will be identifying all the user to IP mappings, and the traffic coming in from the user will be identified on the traffic logs based on his AD name. So let's say your company is abbreviated as KCD or something. So KCD's /Navin will be the AD name of the user. So whomever is in the domain KCD, he will be, or maybe let's say network journey NJ. So whomever belongs to network journey, he will be in the domain NJ, and then his username would look like NJ Kumar. So the traffic log will look something like the IP address of the user and who actually the user is, maybe this guy, and then the destination IP. destination port number, application, allow or deny, which rule he is basically hitting for this specific traffic. So all those information will be there as a part of traffic log. But the most important thing here is you are able to identify which user is basically accessing what in that traffic log, which will be easy for you to know what's the username of the user itself to know who's accessing what, right? So that's about user ID. So adding up, you will have a lot of features that you might consider using when you're using an next generation firewall. So maybe you can identify or track the traffic based on the profiles that you security profiles that you provide on the firewall, configure on the firewall, and put it on the security policy. So with the profiles include antivirus, spyware, file blocking, URL filtering, etc. So each has its own way of analyzing the traffic, analyzing the content of the traffic, and taking a specific action depending on the profile that we have defined or the action item that we have defined for that specific profile. So this will probably be the most important part of a feature that Palo Alto might provide, apart from all those that we have seen so far. We will be seeing in depth of all the features that the firewall might offer you or is going to offer you in the upcoming sessions. But so far, you just know that it's going to offer much more than doing a routing or a layer 3, layer 4 inspection. Okay, so now I guess you might have had a brief idea of how or what a security device or a firewall is about and why it's actually required in the market. So if you understand that, you understand why you actually need to get into security and why it is the boom in the market. So if you can secure your corporate network or your enterprise network to this level by using a firewall hardware, rather than using a traditional hardware, using a next generation firewall hardware is going to do this much for you. You understand why that the next generation firewall or security is the most wanted technology that you wanted to know in the market. Okay. All right. Okay, so we saw. Okay, so I would like you guys to answer a question in the chat on what layer of OSI model that a firewall will fit in. So any accurate or a straightforward answer to this? Anyone in chat? If you'll be able to chat me. Don't have to voice out, but you can just type in chat. I can just take a random candidate's answer and explain you why. Okay, most people are going to say are probably saying, I get a mix of answers, but most of them say it's 3, 4, and 7, which is probably right. And if you are saying only 7, maybe they are considering it's up to layer 7. That's also I can take that answer also a valid one, but let us discuss that in for a couple of minutes here. So when you consider firewall, I spoke about spoke about all these features earlier for a reason. I could have spoke about any features, but I spoke about only specific features here and gave a brief of what it would do or what it does. Why? Because when I talk about a user, he is the core person who initiates something, and that's what you're going to see on the firewall, isn't it? So if he is not doing anything, there is no traffic that you will be seeing on the firewall. So layer 7, and the content he is going to access, maybe HTTPS or FTP, all those applications are layer 7. So are we inspecting anything in layer 7? Obviously, yes. Why? Because if he is going to have HTTPS, which is an SSL session, or if he's going to have an SSH session, and there is something called a decryption policy feature that you have in Palo Alto, where you will be able to decrypt your secure socket layer or SSL specific traffic if you have a policy specifically defined for that. So since you are able to do that and also able to identify which user is accessing what, obviously it's going to do inspection upon layer 7. So that's ideal. And layer 6 and 5, it's probably fragmenting and presenting a data in terms of OSI layer. If you know OSI layer well, 6 and 7 is not going to do anything with respect to processing a packet. It's going to do presentation of the data, and it's going to do some sort of data manipulation for us to get the data presented in a way that a user could understand or a computer could understand. So either way, which flow of OSI model we are looking at. Okay, so we are not going to consider 5 and 6. So considering layer 7, yes, it's going to inspect layer 7. And if you consider layer 4 and layer 3, so if you just think in layman terms, we are going to replace an ASA firewall like firewall, which is doing layer 4 and layer 3 inspection, to be replaced with the next generation firewall. So obviously you will expect this firewall also to do the same thing and much more, isn't it? So without getting into any technical verses, you are going to guess that layer 3 and layer 4 will already be covered, will be taken care of in next generation firewall. Obviously, yes, it's going to do layer 3 inspection, which is stateful inspection. As I spoke about that in ASA, it's also going to be a part of a feature in Palo Alto. It's also going to do a stateful inspection. Layer 4, yes, application, or it's going to identify which protocol it is, and it's going to inspect traffic based on protocol and port number as well. So it's going to identify the application, all right. And also there will be a column that you will be defining in the security policy for you to define what service port for that application you will be using. So that's about layer 4 inspection. So it's going to inspect whether the traffic is a TCP or a UDP, the state of the traffic. So what do you mean by the state of the traffic? Yeah, probably I'll do that explanation when we get into packet flow. So it's basically knowing which which TCP flag or which TCP packet will be first in a TCP initialization session, and which will be next. So the first expected packet in TCP is SYN. So if it's not SYN and if it's something else, it's not the proper state of the packet, and it will be discarding it. So we'll see that see about it when we talk about packet flow. So the answer is it's going to inspect layer 7, layer 4, and layer 3. Obviously, right? Okay. So we have, so I probably will be taking you over the dashboard and management IP configuration. Maybe then we'll get into packet flow. That's how I have aligned it, but maybe we'll take a look at the packet flow first, and then the dashboard overview, and then we'll be finishing off the session for rest to come tomorrow. Okay. So to demonstrate the packet flow, I have a diagram that I have taken from nowhere but the Palo Alto website itself, which is something that you probably have to look into if you're preparing for an interview, or if you wanted to get hands-on with how the traffic flows through a firewall. This is the best documentation you will ever come across. And one more reason why I say Palo Alto is again leading in the market in terms of administrator's perspective. It has the best documentation that I've seen for any other firewall. So if you look at the documentation, you know, in terms of forum knowledge base, in terms of the actual study documentation, Palo Alto has the best documentation in my opinion. Okay, so you probably will be looking at the packet flow for any layer 3 device. Let's say a router, there'll be two stages by default. So it's going to do an ingress and egress stage. So how the packet comes in, how to track the routing information, how to track what's next hop, and then how to track on what the interface has to take to reach the next hop. So by default, any layer 3 network device will have two stages of processing a packet, which is ingress and egress stage. Similarly, for a layer for a next generation firewall here, which is also a layer 3 device, you have ingress and egress stages. So looking at ingress stage first, your packet will be received in, and in here, over here, the traffic will probably be analyzed for extracting some basic information. So which will probably include your source IP, destination IP, source MAC address, source. Just give me a second. Sorry about that, guys. So source IP, destination IP, and source zone. It will be looking at or analyzing the ingress interface. Okay. Source and destination port. Probably that should be it. So you have this many informations that it collects when the packet is received inside an interface. I have a question in here. Just give me a second. Okay, so there is a question. User ID requesting is coming from genuine source AD, like any authentication and authorization mechanism in place. Okay, so the answer to this question, so you are going to define who is the Active Directory, and you will be defining some sort of you'll be defining an IP address of the AD, and you will be defining on the Active Directory, you will be defining a username and password that the AD should use to log into the firewall. So without you defining or administrator defining anything, you will not be able to come to a conclusion on which AD server is going to get authenticated to the firewall and pull all the information of the user. Okay. So basically, your firewall will have the AD's IP address, and it will have the protocol for Active Directory LDAP protocol enabled on the firewall to contact the AD, and the AD, once contacted, will be logging into the firewall using a specific username that we have provided on the Active Directory, and then it gets in sync, and once the sync is successful, only then the AD username and IP address mapping will be pushed over to the firewall, and the firewall identifies the user's traffic based on the username and IP address. So without you providing anything, it's not going to do anything as such of contacting any third-party AD or anything, any unauthorized server. Okay. So when the packet gets to the ingress stage, it probably will be looking for all these 6 information. Once it has all of them, it's going to do some analysis to do an ingress processing error check. So it does it with respect to layer 2, layer 3, and layer 4. So with respect to layer 2, it just identifies the destination MAC address. So you know how the MAC address is being learned on any device. So it identifies the next hop or the destination MAC address. And once the destination MAC address is figured out, it identifies which interface it has to get the to identify the MAC address interface where it can get that MAC address from. It will check if that can be identified. If not, it discards the packet. That's about layer 2, how it processes the ingress processing error. And again, it checks for the layer 2 checksum errors and all those layer 2 errors that you might come across in any networking device. All right. So with respect to layer 3, it does a couple of checks where if it checks for the TTL value. If it is 0, it's going to discard it. And it checks if there is any sort of attack, any sort of DOS attack that's being sent as a part of this packet. Let's say if it's going to be an ICMP flood or a UDP flood or anything of such sort. In that case, it's going to identify the pattern and discard it right there. And again, it's going to check for the IP checksum errors as well. Okay, so in terms of layer 4, it's again going to check if the traffic is a TCP or UDP. Upon checking that, it checks if it's a TCP, it checks the state of the packet. It's going to be a SYN if it's a first packet. If not, it's going to discard it and throw it away. It will check if there is any if it's a retransmitted packet, or if it's a packet, if it's a TCP truncated packet. So what does that mean? It also applies to a layer 2 and layer 3 processing error check, where truncated in the sense it's going to identify or imply that some bytes are missing on the path, and the expected bytes and the received bytes are not matching. In that case, it will throw an error called TCP truncated error. So it could be because of any reason, but it checks if that's the case. And if that is the case, it's going to discard, and then until the packet arrives, it's going to wait. Okay, so likewise, it does the process check, process error, ingress process error check for layer 2 through layer 4. All right. Okay, so and also it again checks for checks if the firewall inspections are applicable for that packet or not. So how does that do that? It's going to do it through something that you see here, where, so if you see this table, this is a table that you're going to look up if it has to identify whether the traffic has to be inspected or not. So based on what packet type it is and what interface mode that it operates on, it's going to check and identify whether the traffic is going to get inspected or forwarded or dropped, or only forwarded or only dropped or only inspected. So whatever it might be. So considering a simple IP for unicast and layer 3, it's going to inspect and forward the traffic ideally. So if it's going to be a broadcast, and if it's a layer 2, it's just going to forward. It's a flood. So it applies for the ARP packet, isn't it? So if it's an ARP broadcast, that's a broadcast done for identifying any MAC address to that of an IP address. It floods the traffic. It floods the packets to all the interfaces. So in that case, it only does forwarding. It doesn't inspect. So similarly, if you consider for multicast, again, it's going to flood the traffic only to that multicast IPs. So consider any routing protocol for that matter, EAGRP, OSPF. So it does do multicast for only the specific OSPF routers that are part of the same process as that of the router, which is going to, or as that of the firewall, which is doing OSPF with that. Okay, so likewise, so you don't have to worry about virtual wire or tap. These are two different modes of interface modes that you will be coming across when you learn Palo Alto. I will be talking about this in the session in depth, but right now you can probably ignore this. So all you know is layer 2 and layer 3 currently. Probably you can just concentrate and maybe look at this table later on after the session to know how does it identifies whether traffic has to be inspected or not. Okay, so moving forward, so it just checks if it's inspection applicable or not. If it is not inspection applicable, if it's going to be a ARP flood, it's going to directly egress it. Okay. So if it's an inspection applicable packet, it checks if it's an SSL VPN or IPsec VPN tunnel packet. If it's so, it does a decryption and processes the packet again. And obviously, if it's an IPsec packet in the egress stage, it's going to de-encrypt and then push it back, push it out to the egress interface. Okay, so this is ingress stage. So we will be looking into 3 more stages: set up slow path or fast path, application identification, and content ID. Okay, so when you come down to slow path, so slow path is when the traffic is the specific traffic, let's say from IP address 10.1.1.1 to anything in the internet. If it's the first packet that's seen on the firewall for this flow, it's going to enter slow path. So that's what is seen here. So if it's a first packet, obviously it will not have a session that's available on the firewall already. So it's going to be a new session that has to be formed, right? So it will come to slow path. If there is already a session available, and as you know, TCP idle timeout is 1 hour. So let's say 30 minutes back, there was a session for a source IP to that of a destination IP for a specific port number. The same match is going to initiate another traffic. And if it's within 1 hour of idle time, it's going to use up the same session. So that's why it checks if the session match is found or not. Okay, so considering it's a new traffic, it comes to the session setup or slow path. Over here, it gets the egress interface. It gets next hop routing information. So before it does that, there is something called just give me 1 second. I just forgot that name. Just give me 1 second, guys. Before it gets to routing, it checks for the routing information. It probably will be checking policy-based routing. Oh, sorry, I just forgot that name on the way. So it has a feature called policy-based forwarding. So where let's say you have an ISP and you got to forward all the traffic through that ISP, and you have a secondary ISP. Maybe that ISP is just for the specific team to use. Maybe they need a better bandwidth. They don't want to share common ISP that other people share in the office. So only for them, you will define a policy-based forwarding rule. It's like a security policy rule. You will define that rule saying traffic coming from this set of IP or this network, it has to egress out through the secondary ISP interface, not the actual ISP interface. Whereas your default route for your primary ISP will be pointing to a specific IP address. So that's for the whole office. But this policy-based forwarding rule will say, for this specific network, you egress out through this interface. So basically, before checking the routing, it checks if for this specific traffic there is any policy-based forwarding rule. Okay, and then checks the routing, identifies the egress interface, zone, and layer 3 routing information, all those stuff, and then gets to NAT policy lookup. So over here, there is a specific reason why if it checks if it's a destination NATed traffic. So let me take a moment to explain this in a notepad. So you have a firewall, and let's say a user from outside is trying to access server in DMZ. So obviously he is a user from outside. He is not a part of this corporate network. He will probably be accessing a public IP, and that IP will be translated to the internal IP, let's say 10.1.1.1. So let's say the public IP is 200.200.200.10, and he'll be accessing this IP, and this IP will be translated to 10.1.1.1. So it's basically a destination NAT traffic. The destination IP is getting NATed to 10.1.1.1, isn't it? So in this case, so if you look at the actual packet in terms of the user, he's accessing, so he'll be coming from his own ISP's public IP, and he'll be accessing this public IP. So let's say this interface is a part of untrust zone. So the zone name of the zone is untrust. So the traffic coming in from the user, he is also from internet untrust zone, and the IP is accessing is also a public IP, that's also untrust zone. So when you try to analyze the actual packet, it's untrust to untrust. Whereas after the NAT translation happens, it's basically going to switch, the destination is going to switch from untrust to DMZ zone. Let's say this zone is DMZ. So since this switch happens in terms of destination NAT traffic, the routing also has to take a turn to identify which egress zone or egress interface it has to point to reach this IP. So ultimately it has to reach the IP address of the original DMZ server, isn't it? So to do that, since it's a destination NAT traffic, it has to go ahead and do a lookup of routing again in case if it's a destination NAT traffic. Okay, so it does the egress zone and routing lookup again, and then comes down. Okay, so that's the whole point of doing the routing lookup again if it's a destination NAT traffic. Okay, I hope it's clear. Then it does a security policy match. So I told you that there is a feature called application identification, and in security policy there is a field where we select which application has to be allowed or denied for a user, isn't it? So if it does a firewall security policy lookup in this session setup stage, and the application ID process happens late in the later stages. So what do you think would be the lookup that is done here? So it's going to say application as any, and then looks up for other parameters with application as any, because it's going to look up for security policy again in here once the application is identified. All right. So before that application is identified, just to do a dummy lookup by excluding the application, it takes the application as any, considers it as any, and then it checks for the other parameters whether it's allowed or not. So if it's allowed, it creates a session. If it's not, it discards. So once the session is created, it comes directly to the stage. Okay. So over here, what it does, it checks for the session active state. So if it's a TCP or a UDP, if it's UDP, it's not going to form a session, so you can ignore that. If it's a TCP, it checks if it's in active state, which means if the first packet that's sent is a SYN, and the second packet is SYNAC, and third packet is acknowledgement, and then the data. So if there is any change in this pattern, it's going to discard the traffic. And then it does the NAT also here. So the NAT actually gets applied here, but the NAT lookup happens here. Okay, know the difference. So it's going to get applied in this fast path. It's going to be detected or identified or looked up over here in this slow path. So once this is done, it checks if the traffic is bound to have a decryption policy. So if the traffic is SSL encrypted, and if you do have a decryption policy in place for the traffic will be decrypted. Okay, if not, it will be not. Okay, over here. So once the traffic is reaching this stage, here is when something called SP3 architecture kicks in. So it's nothing but single path parallel processing. So it's coming to say nothing but anything that happens after this is going to happen parallelly. So it's going to happen all together at once. So you have two more phases here, excluding egress stage, and if you just see excluding egress stage, you have content inspection and you have application identification. So these two stages will be done parallelly to avoid the processing time, because it's going to do a lot of checks in here. It's going to do some protocol parsing to identify the application. It's going to do application decoding. It's going to do antivirus profile check. It's going to do file blocking check. It's going to do URL filtering. And on top of that, it's going to identify the application based on the pattern that it has. So when it's going to do so much, Palo Alto has designed it in such a way that everything happens in a parallel manner, both content inspection and application identification, so that the processing happens quicker and the traffic is egressed out of the firewall as quick as possible. Okay. So when you take application identification, first, it checks if there is an application override policy match. So it's nothing but a custom application that you probably will be configuring on your firewall. That will be checked if it matches the custom application override policy match, if there is an application policy available. If yes, it checks for the security policy. If not, it identifies the application based on the pattern that it has. So it has a specific pattern for it to identify an application. So let's say if it's an HTTP, the first if you just check the HTML version of HTTP traffic, you will see HTML get request as the first packet, isn't it? HTML get request as the first packet, and then that's followed by put, and then it follows along to identify what exactly happens inside the HTTPS traffic. So likewise, it has a specific pattern for each application that it has in its database, AppID database, and it gets updated time to time. Once any legitimate application comes inside the market, it will be identified and it will be a part of the Palo Alto AppID database. So with that sort of pattern identification, it identifies the application. So if it's not matching the AppID override, it's going to check based upon the pattern, and then it's going to look up the security policy if that application is allowed. And if yes, it's going to set up the content inspection here. And once content inspection kicks in over here, it's going to see, I hope someone else has pinged me something. Just give me a second, or maybe I'll look at it after I'm done with this one. Okay, so with respect to content inspection, so I told you earlier that the firewall is capable of identifying the subset of applications where if the first application is SSL, and next is Facebook, and next is Facebook chat. So how it does that is that once the base application is identified here and content inspection kicks in, the content inspection does something called protocol parsing or decoding to identify if there is any inbuilt or secondary application that the user is basically accessing before he finishes the session with the end application. So let's say he's accessing about 3 to 4 applications inline. It will be able to identify up to the last application that he is accessing. So with the help of protocol parsing or decoding. So not to get into the details of how the firewall does it in software level, but it's good to know that it is capable of doing so using something called protocol parsing or decoding. Okay, and then obviously it checks for all the content inspection profiles that we would have defined in the security policy, where which is antivirus, spyware, wildfire. That's again a feature which we'll be discussing in brief. File blocking. You have URL filtering. You probably have maybe one more. I'm just missing out something, but then these are all the security profiles that we would have defined, and for each DOS protection, so denial of service profile. So these are the profiles that we would have defined, and for each profile we will have a certain match criteria and threshold, and if that threshold breaches, we will have an action item to take. So based upon the action, this will probably be added to the security policy at last, as an option, as a parameter. So based on the action item, the traffic will obviously be denied or allowed. Or maybe you also have other options like drop, silent drop. You have features to say that the traffic can be allowed, but upon user's confirmation. So you will be asked or want to access this URL, but then if you give continue, you will be allowed to access. So all those action items can be taken with respect to the profiles that you define and the result that comes out. Okay, that's about it. And later on, after all the content inspection is reviewed, it again checks if the SSL decryption has happened earlier that we saw. If it has decrypted any SSL traffic with the help of decryption rule, it re-encrypts it back again and sends it out to egress stage. So in the egress stage, it again checks for what's the outside interface, and it checks if if there is any QoS shaping that has to be defined, and if the fragment bit is set on the IP packet, if the fragment bit is set on the layer 2 packet, layer 2 header, it will be fragmenting the data if applicable. And if it's a tunnel interface, again, it has to encrypt it, again, process it again. So, and then gets the packet transmitted out and then gets out of the firewall. So this all happens within a fraction of milliseconds. It's not going to take as much as time that we took to explain this, but these many steps are happening for a packet to get in and then get out of the firewall. Okay. Okay, so I believe we have about 25 to 30 minutes left. I will be going over a couple of labs that was a part of the agenda. Maybe a few of them was management IP config, packet flow is done. CLI troubleshooting, maybe we'll look at this tomorrow after we demonstrate a simple lab on any of the topic. Packet capture, backup restore, and administrator. All right. Okay. So I guess my firewall is on. It should have got an IP. So let me explain you. So this is how the connectivity on your actual lab that I showed you earlier in the start of the session would look like as well. I probably would have connected it to the management cloud everywhere, wherever I'm using the Palo Alto firewall. So what this does is, this management cloud is nothing but our own PC where I'm accessing this lab. Okay, so if you check the machine that I'm on currently, it should also have an IP on this same subnet 172.16.24.x, and the EVNG also has it on the same subnet, and that is the network that I'm connecting to the management interface as well as the outside interface. So what this does is, this acts as a DHCP server and provides an IP on the same subnet to the firewall management interface, and by doing so, like I'm accessing the EVNG on the browser, I will be able to access my firewall as well. All right. So let me just check if I've got the IP. I did get an IP 172.16.24.143. So it's of the same subnet as I said. 24.1 is the gateway. So let me just try to log into the firewall CLI to show you how a management interface is configured. So the default username and password is admin and admin. So username, password, both will be admin. And I'll be asked to change the password on my first login. Once I do, it'll let me in and I'll be inside the firewall. So the firewall prompt will say username @host name of the firewall. So right now the firewall's host name is PA-VM and the user who was logged in is admin. All right. So right now in Cisco terms, if you see, I am in privilege mode. I am not yet in config mode. So here I'll be able to run any sort of show commands. Okay. But will not be able to configure anything yet. So when I have to configure something, what I do, I go to, before that, I'll just show you how do you check the interface status. So if I say show interface all, I don't have any interfaces active and up and running right now, which means the data interfaces. So when I do show interface all, it is going to show me only the data interfaces. You might say that I have logged into the firewall, or I have an IP address of the management interface, but for you to check what the status of management interface or the configuration of it, you got to specifically go to show interface management. So over here, you'll be able to see the IP address, and net mask, and the gateway, MAC address, and so on and so forth, and the traffic through the management interface and stuff like that. So I'm getting into config mode. So I'm just going to show you on how do you do management interface configuration, but I'll not be configuring it because I already have an IP address through DHCP. So I do configure. I will be in configuration mode, as you could see. So once I'm in config mode, so any configuration you do starts with set. Okay. So if I do set and question mark, you have wide range of configurations you could do. So if you just compare your GUI with that of your CLI commands, it'll be easy for you to, I'm just exiting and then show interface management. So the IP is 143, isn't it? So I'm going to the browser. I'm giving 143. So once I log in, you will be seeing a lot of options, but for now, I would like to show you on how can you probably more or less figure out how a CLI command would look like. You can probably guess 80% on how the pattern of the command for any configuration in CLI would look like by checking this GUI tabs that we are getting in. So now I'm about to configure a management interface, isn't it? So when I'm configuring a management interface, first of all, I need to know which tab I should get in to configure management interface through GUI. So I'm in device and interfaces, device setup interfaces. So this is where I have management interface, and this is where I can configure them. So I have a DHCP. So if I just check the DHCP parameters, I see all the information here. So I by default have HTTPS, SSH, and ping enabled, and that is the reason why I'm able to log into the firewall through SSH, CLI, as well as GUI. And obviously, I will be able to ping if I'm in the same network or if I have connectivity, obviously. So the reason why I logged in and showed you this is you are in device, you are in setup, and then interfaces. So when you got to configure the same on your CLI, you first go to configure mode. Over here, you got to set, do a set command first. And say device config. So why? I'm actually going to device tab and then going to setup interfaces, right? So I have to go to device config, and then if I give a question mark, obviously I'll be able to figure out if I have to configure interface, set device config system, IP address. Tab will help you obviously in Palo Alto as well, like Cisco. And I give an IP 10.1.1.1. And if you give a question mark, I have to configure net mask. Next, net mask 255.255.255.0. And if I give a question mark, and again, probably I need a gateway. Maybe it's a default gateway. And then I give a default gateway 10.1.1.10. So you also have some other options that you could do, but this should be sufficient for you to configure just the IP address. So once you do this, there's something called commit that you have to do. So unless and until you do a commit, you will not be able to experience anything of whatever configurations you have done on the firewall. So it won't be applying to the firewall unless you commit the changes. All right. So that's how you configure a management interface. Once you do that, you got to commit the change. So the command for it is commit. And once you commit, you got to see what is the status of the commit. You got to do show jobs all. So there'll be a inbuilt job that will be running for everything you do on the firewall. So for anything that's happening on the firewall, that's a job. So if I do show jobs all, I'm not seeing anything because I didn't do anything yet. So it just says auto commit, type is autocom. So this is when I changed my password. When I changed my password first time, it's going to do a commit automatically. So that is the reason why I'm able to log into the same password again, right? Okay. So that's about configuring a management interface. I'll talk about commits later on. There are some things you might need to know if you got to do a proper commit without screwing up anything. So let's go ahead and review the dashboard once. So the dashboard will have some basic information on who has logged in admins. Data logs, nothing here because no data traffic. System logs. System log is something that your firewall basically, what exactly is happening on the firewall. So you have two types of traffic, isn't it? So you have data plane and control plane. So data plane is for data traffic, management plane or control plane is for your management traffic that's happening on the firewall, right? So these are all that you see on the system logs is something that's happening on the management plane or control plane. That's happening on the firewall. So I have logged in through web GUI and I've authenticated, password changed. Okay, I authenticated through console or telnet. So update server is successfully connected. So this is a server that Palo Alto contacts for any updates that it requires, updates.paloaltonetworks.com. So anything that the firewall does or firewall that's happening on the firewall for the firewall or by the firewall is going to be logged here on the system logs. All right. So again, that's some basic information about the firewall, like its host name, serial number, the versions and stuff like that. It's time, uptime, and all those stuff, and the resources here. And ACC monitor, I told you that you have a graphical dashboard on to see what exactly is happening in the network. So that's about this one. So you'll be able to see based on how much bytes the traffic is being accessed or the resources are accessed, based on sessions, based on threads, content, URL, and users. So that applies for application usage, user activity. So you can just go over this one, and you can even filter based on what time in a day you need to review this logs. Monitor, it's about reviewing it based on a GUI view. So traffic log, as usual, you will see from zone to zone, who's the source IP, who's the source user, destination IP. You will also be able to see application action, which rule it is hitting, and all those stuff. Threat, URL filtering, all these are logs with respect to security profiles that we spoke about, the content inspection, right? So the decryption, so all those have a separate log. And also, obviously, I told you about the system logs. You will see something here already. So that's the same log that you see on the dashboard, that you just saw on the dashboard. So this is the ideal way of coming to the system log and seeing what severity it is and all those stuff. But if you just have to have a quick view, you go to dashboard and see the system logs. Both are one and the same. Okay. And PDF reports. So these things, you probably will not be using it that much. So it's all a graphical view of what you saw up right there. So threat logs, you have a threat map, threat monitor. So you got to say, you can set up a monitor, network monitor, traffic map. So all those, there's a graphical view of probably what you just saw up there. Okay, I personally have not used anything here. So session browser, it's with respect to the specific session. So if a session is formed, or if a session is about to form, or if it's failed, you probably will see them up here. Okay, so you can generate reports over here as to which, if you want to generate a report based on a specific user activity, report group. So if you have to group multiple reports, if you got to take a report and send it to an email address, you can do that. Coming to policy, various policies. So we spoke about NAT security policy, policy-based forwarding before it checks for the routing, QoS, decryption. So all those stuffs that we discussed, application override, all those that we discussed in the packet flow, all the policies will be configured up here. And some sort of filtering that you might do, optimization. So unused rules in 30 days, 90 days. So you can just filter them and see which rules are not being used, and you can maybe clean them up to make it look better. Objects, straightforward, address group. You have application group, server, service group. This is the port numbers and protocols. Application is again application ID, address group, IP address, FQD, and objects that you define and use it on the security policy or elsewhere. Coming down here, these are all the security profiles that we spoke about for the content ID inspection. Okay, decryption profile. This is with respect to SD-WAN. Okay, log forwarding profile. So again, when you come to network, you will see some network profiles here. Those are security profiles. These are network profiles. So network profile will have specifics with respect to IPsec configuration, and also it will have QoS and LLDP profile that you might define. And also you have service profile. Probably you will be seeing them here, or maybe in device. Yeah, in device you will see service profile, server profile, sorry. So based on what services you need to configure on the firewall, you can define a profile and then call them up. Okay, so this device tab is basically going to be for configuration based on whatever you have, whatever you got to configure for the firewall. So maybe with respect to administrator management interface, high availability, user ID. So all those stuff will be configured here. Under network, you will have routing, VLANs, zones, interfaces, DHCP, DNS, IPsec related configs, zone protection, all those stuff will be here. Okay, so apart from this, you have an area where you commit the configuration. So I told you I'll be talking about commit, which I'll do later. So it's basically saving your changes, only then it gets applied. So this is again something called taking logs. So if you're working on some critical project and if you don't want anyone to mess up by committing your changes, you can take a log, and that will not let anyone else to commit the changes on the firewall for that time period. Maybe you can revert the log, remove the log, only if you're a super user. You have that privilege, right? So this one, save the changes and revert the changes. So if you have not committed any changes, but you have made some changes, you can revert that here. All right. So that's about an overview of the dashboard. Let's see what we have next. Management IP is done. I guess we will stop here. We will have, maybe I will add one more. So this will probably give you an idea on how you configure or touch base on configuring security policy NAT, basic NAT for a user to access internet, right? So probably we'll do this lab. Administrator, backup restore, packet capture, and CLI tomorrow. I think it's all lab, so it will be straightforward. I'll just start with configuring things, and then we'll be able to finish it off tomorrow. So we'll be calling it a day, and maybe I'll be opening up the forum for any questions so far.
Hi, Navin. Myself,
Yeah.
Mani. So this I didn't join the initial after 20 minutes something in the middle of the class I joined. So just want to know this 5-in-1 class, right? It's started from today, the demonstration,
Yes.
I believe. So just to know about the each appliances when you're giving the training is kind of a on certification point of view or just kind of a knowledge, and it's kind of a professional level or kind of a, let's say for if next generation firewall we talk about this Cisco Firepower, right, FTD. So
Yes.
it's kind of a CC security level or kind of a NP level.
Okay, you can go ahead. And I'm to be frank, regarding FTD, I don't have the exact course content with me, because I'll be covering up Palo Alto and FortiGate for you guys. But if you go to this URL, let me paste that for you here. You will be able to download what topics that you'll be covering up. And if you have any further questions, you will probably be able to contact the backend team while you enroll for it. But with respect to Palo Alto and FortiGate, Palo Alto, we will cover PC and SE, and introduction to Panorama, with some basic automation stuff that I will be covering as an add-on. For FortiGate, I will be covering NSE4.
NSE4, okay.
Yeah. So for FortiGate, it will be the next session coming up after you finish off Palo Alto. So once Palo Alto is done, you will be covering up FortiGate with me, and then following that, another trainer, another of our faculty will be covering.
Okay, so
other
this
firewall.
PCNSE, how many hours or how many days or weeks?
So in my experience, I have completed this in 30 to 35 or 40 hours max, depending on how interactive the session is. If it's more interactive, it takes some time for me to move around with the topics. If it's going to be only I'm talking in the session, and if there is no interaction, it probably will be ending up pretty soon, but it will be somewhere around 30 to 40 hours.
So PCNSE level, including some kind of a TAC level troubleshooting, troubleshooting point of view.
Troubleshooting, it's not a part of PCNSE, it's an administrator course. So for troubleshooting, you have a separate course that is designed by Palo Alto. If you just go check.
Okay.
For troubleshooting, it's a separate paper itself, like you do for PCNSA or NSE. For troubleshooting, it's again a separate paper that you have to go across.
So Panorama will not be covered, right?
Panorama basics, yes. I will be. I'm actually trying to deploy this Panorama in AWS. So if it comes out well, I will be covering on how you configure device group, how you configure templates, and how to use them, and how do you join the firewall to Panorama. So some high level idea on when that will be really helpful, because everywhere you study or work in Palo Alto, you will be working with Panorama management. So it's not going to be a standalone firewall most of the cases. So only for that reason, and to stand out from other institutes, I have probably I'll be probably introducing you to Palo Alto Panorama as well, because without that, it is going to be just as good as having a theoretical knowledge of Palo Alto, because Panorama, managing a firewall through Panorama is completely different. So that is the reason I'm planning to do it as a session itself, probably a 2 to 4 hour session, as I have planned for Panorama alone.
Okay, so initially you had mentioned multiple retake. Whoever joined the course. So in case of they couldn't attend any particular firewall or due to the work, they can join some other classes, right? But you mentioned the racks are a limited time. It's a racks mean you have the physical appliances, which is
No, we'll be providing you an RDP session. It's all a VM. It's all the VM that we provide. So we'll be providing you the necessary lab, and I believe you'll be having the lab access for about 5 months, 5 to 6 months, I guess.
You mean the topology which you have created, right?
That's correct.
It could be the VM only.
Yeah, it is a VM. Yes, right.
But VM, we can set up our own topology, right? I mean,
You can, but what about the resources? Let's say you wanted to run a Windows server with a Windows PC, 2 Palo Alto firewalls, maybe 3 running a HA and then forming an IPsec VPN. So I don't think even a 16 GB laptop would support or run properly with that. So
yeah, of course,
that's the only
we
reason.
may need EVNG or a Google Cloud along with some images from PCs or and all. We can
So only to make sure you should not be limited to accessing the lab because of the reason you don't have the resources with you, proper compatible laptop with you. You shouldn't be restricted to that. Because of that reason, we are coming up with the
okay.
Lab setup that we are providing. So with
So-
this, you don't have to probably worry about how many devices you're turning on. Obviously, once you're done with it, it's always good to turn them off for others to use. But mostly you will not face any issues with respect to switching on multiple devices.
Okay, so only if okay, some limited time we can use the rack. So you are suggesting minimum 32 GB something, right? For I mean,
I can okay, you can even practice Palo Alto with an 8 GB RAM.
I
But
was trying to install VM. It was been we can allocate you know the VM and then ENet all these stuffs and all. But 8 GB is not sufficient. 16 GB, so 8 GB you can allocate.
8 GB is not sufficient, but mostly you will be able to demonstrate 70% of the topics with one Palo Alto. Maybe for HA you might need 2. For VPN setup you might need 2. So it depends on what sort of lab that you're practicing. Otherwise, for most of the topics with one firewall and maybe one router and switch, I think you will be able to demonstrate most of them. Yeah, as you said, 16 GB also will not be enough if you want to demonstrate a few labs, like if you want to have a Windows server deployed, if you wanted to do a DHCP relay and DHCP is running on some other router or a Windows server, and that's going to consume a lot of RAM. So
yeah,
few labs will not be possible even with a 16 GB. But yeah, that is the reason why we are providing each and every one of you with our lab rack.
I think workstation kind of stuffs we need for all the appliances. We can put it the laptop topology, right? Or EVNG or Google Cloud only.
I'm not sure about that. Backend team is taking care of the lab setup. Even I'll be provided with my own lab access for me to access and get the things delivered to you. But yeah, you can talk about that with the backend team when you get to contact them. Maybe this contact number would help you.
Yeah. So Sahar will take other firewall, right?
Not sure of who is the trainer. You can inquire on who is that.
No
From my side, I will be taking or covering Palo Alto and FortiGate.
Yeah, thank you,
Yeah.
Navin.
All right.
Hey, Naveen, just a question. So basically, the flowchart which you shared, it
Yes.
has two slow path and fast path. So why do
Yes.
we call it slow path and fast path?
That's how they have named it. If you consider you have multiple NAT.
I mean, since I guess the first slow path is just to establish the session.
Yeah, that's right.
That's
That's you might guess it that way, but I could say that that's how Palo Alto has named it. So Cisco has named its NAT types as AutoNAT, twice NAT. So I don't know if there is a reason, but few things it's how they name it. So we got to just follow them. Yeah, as you said, the reasoning. If you got to give a reason, it's something what you said. It can apply to what you said. Since it is forming a session, forming a new session, it's a slow path. Since if it has a session already built in and it's going to use up that session available in the firewall, it's going to take a fast track and then contact the fast path stage and then go down.
Okay. And in this scenario, the session which you talked about, So the firewall going to form that session with the outside user who's trying to access the DMZ server, or within the network with the DMZ? Which side it will form the session?
I didn't get you. Can you come
I mean,
again?
yeah, you talked about one of the user trying to access the DMZ server via the firewall from the
That's right.
outside network.
Yes.
Yeah, so this session will be got set up between from the outside user to the DMZ or from the firewall. On which side?
So session will be set up on the firewall, obviously, because we are talking about the firewall. So if you think of what the session table would look like, it would look like user coming from outside. That's public IP of the user, and the destination will be the user's private IP.
Okay, so this would be between the firewall and the user.
That's right.
All right. Since going to the DMZ, that is a secured network and trusted network, you mean?
Basically, it's not what exactly you're trying to say, but let me try to get to the diagram here. So
Okay.
you are trying to talk about this firewall and having this server here.
Yes.
And a user coming in this way, and this guy is having a public IP. And he's going to access a public IP. And since he's not a part of this corporate company, he is maybe going to, this is a public hosted server, let's say, and he's basically going to access this IP address, which is public, and this will be NATed to this private IP address. Let's say it's 10.1.1.1.
Yeah.
So your question is how the session would be formed in this case. So when the traffic
Between
is received,
between which 2 points the session will be formed?
so it will be formed for this source IP
Okay.
and this destination IP, and
Okay.
the egress zone or interface will be this one. So that is the reason why in the packet flow we checked for the routing, egress interface, and zone. For a destination NAT traffic, we check them again. So if it's a destination NAT traffic, like in this case, the IP address will be pre-NATed IP, and the zone and egress interface will be post-NAT zone. So once the NAT happens, the zone that implies to after the NAT happens for this public IP to private IP. So this zone or this egress interface will be the zone or interface that the traffic will be going out from. So the session would probably look like, let's say this guy is 1.1.1.5. This is a source, and the source zone will be untrust, as he is from the untrust zone. So this is the interface, and he is in this boundary. So anything away from this boundary is untrust zone for the firewall, isn't it?
Yeah.
So he is an untrust user, and the IP that he is accessing. And I said that with respect to IP address, the traffic will be pre-NATed IP. So the public IP that he is accessing will be the IP that will be available on the traffic log, and the zone will be DMZ zone here. So untrust to CMZ, and then the IP address will be public IP. So this is how the firewall will track the connection or the session. So with respect to that, we have to write a security policy as well. So while writing a security policy, you write source IP as any, since the user is coming from outside, and source zone as untrust, and destination IP will be pre-NAT IP, which is the IP address here, 200. And destination zone is DMZ, the post-NAT zone. So this thumb rule you have to keep in mind when writing a rule for a destination NAT traffic. The destination IP will be pre-NAT IP, before NAT, and the destination zone will be post-NAT zone, after NAT. All right. So that's how it will look like in the session browser or traffic log as well.
Okay. Yeah. So that was the catch there. Yeah, you said the IP and the zone. Yeah.
The IP and the zone should be taken care.
Okay.
Because it also the traffic flow diagram also gives a reason why it is doing that way. Because if the zone is getting changed or the egress interface gets changed, and if the security policy says untrust to untrust, and the IP address also is the public IP to public IP, the traffic will not go anywhere. It will be circling around the untouched zone itself, right? So it's not going to go to the actual DMZ server there.
Okay, thanks. Another quick small question is you showed how to configure the IP. So if when it is a blank device, completely new with the default setup and all, how will it allow us to like SSH or HTTP anything?
Okay, so okay, I'm sorry, I didn't mention that, isn't it? Okay, so when you first purchase a firewall, you have the firewall built in with, I told you what would be the username and password.
Yeah.
But the question is, how do you access the firewall? So the firewall will be built in with an IP of 192.168.1.1. All right.
Okay, got it.
So you will be connecting a PC and you'll be configuring an IP address similar to that same network. It will be /24, I believe. So maybe .2 here, and you will be basically able to HTTPS, SSH, whatever. Because I think I showed you the GUI of management interface config, where
Yes.
the protocols like HTTP, SSH, ping are allowed by default. That's the
Okay. That
that's
would allow
by,
basically.
yeah, that's by default allowed on the firewall for management interface alone, not for the data interfaces. For data interfaces, we'll have to configure them on what protocols to allow accessing the specific IP of the interface. Management interface, this is the case.
Makes sense. Yeah.
Okay.
Thanks for that. So basically, whatever the training you will be taking for the Palo Alto, what would be the duration before another trainer jumps on?
For Palo Alto, as I said to the previous candidate, I think it would take around 30 to 40 hours for me, depending on how the class goes. So if it's, I have completed it somewhere around 32 hours as well. It took me up to 40 hours as well in some batches. So I couldn't comment on what exactly would be the time, but you could consider 35 hours approximately.
And I have done the trainings in past also. Basically, I'm not more into the security, but I aspire to be, learn security and do security stuffs. But since we don't have the, the task to do in day-to-day life, so we basically, move over the knowledge whatever we gather during the time. So like, I don't know, should I learn again security, firewalls and all? Because since I don't have stuff or the job to do, I forget the things again. So like, what do you suggest since you are in security already?
It's always good to learn security, because see, if you are into a cloud infrastructure where you know AWS, or you know Google Cloud, GCP, or you know Azure.
Mm-hmm.
So if you are considering your corporate network or your physical data center to contact your AWS resources, so let's say you have hosted some servers or some multiple servers in your AWS environment, and you have to have a layer of security on your AWS cloud before it reaches your servers behind. Maybe you have a load balancer here and it gets load balanced here. Before it does all this, you need to have a layer of security here. So you need to use some sort of security device in here for your traffic to get inside securely, isn't it? So just give me 1 second. Yeah. So I was talking about having a secure layer, or security layer, before your traffic from your physical DC or corporate network reach your server farms here. So if you consider having a secure layer here, it's obviously going to be a firewall.
True. Yeah, every network basically traffic, whichever the enterprise or any sort of network, first it faces the firewall. I agree on that.
Yeah, obviously. So you AWS says it's 100% secure from their side. Obviously, for their customers, they will have to say it's secure. Even though if it is 100% secure, even though it's true, as a company, as a revenue generating company, you have to trust your device that's deployed inside it, not the vendor that's providing some services to you. So I have seen people who have deployed servers in AWS here, but still have a secure layer by configuring a VM based Palo Alto or FortiGate here for them to filter the traffic and then get in to the server and then come back out. So whatever it is, your security in terms of anything. So you not only learn security based on firewall, you can do a WAF, web application filtering. You can do security based on firewall, or if you need, you can have some. So for enterprise security, firewall is the best. So you need to have a firewall so that it has everything built in it in one device. So it has IDS, it has IPS features, it has WAF features. So it has everything built in one single device. And if you take one license or one single bunch of licenses, you'll be able to execute whatever you wanted to do in security, almost everything. So learning security, even though you are switching to cloud, having a firewall in cloud is also an ideal setup these days. So that you are at least you know that your traffic is passing through your device that you are managing, not through any third-party vendor. They obviously promise that they are securely maintaining your infrastructure, but it's always good to have control over your network from your side. Yeah, it's good to get into security and then learn them as quickly as possible. Obviously, not only security would help you. You should have knowledge on DevOps, cloud, and other stuffs. But when you're into networking and if you're thinking of progressing somewhere further, security is the next step that you should take. Then you might think of other stuffs. Yeah.
Okay. Yeah. Thanks for that and sharing your expertise, technical expertise also. Thanks.
Yeah. Thank you. I guess we are done with the questions. If anyone has any further questions, we have 3 more minutes.
Hello. I know.
Yes.
Yeah. Yeah. Actually, can we get this session, website to see again?
Yeah, obviously you will. In whichever platform you contacted Network Journey, you will have this put up in that platform, say LinkedIn, YouTube,
Okay.
or maybe I think you will be getting this over your email as well, since you have enrolled
Okay.
it before the start of the session. So not to
Okay.
worry, you will be getting it through any platform. Yeah.
Okay. Thank you. Thanks so much.
Okay, guys. I think we have one more session left over tomorrow. We will be going through mostly all the labs that we will be covering that I have posted here.